So everybody should have gotten an invite to a shared folder, a shared Google folder earlier today. And in that folder, you will see that I've put each of the experimental proposals that I've received so far. First thing I'd like to do is just go over quickly um, the milestones where we're at currently and what we still have ahead of us. Right. So here we are. Here are is the program timeline so far. It's a little bit delayed, so it's not May 1st doing the second online meeting. Um, so we're going to have some leeway in all of these milestones. I mean, ideally, we can get everything done on the dates that are on there, but it's understandable that we're getting a little bit of a late start on everything. So it's not super mandatory that you hit these milestones exactly. So our next milestone was originally planned for May 15th. So that would be a logical design of your experiment. So essentially, what it is, how it's going to work, and what sensors exactly you're planning on using. And then June 1st would be the next milestone after that, which would be a physical design, which would have more specifics on exactly which sensors you're using. Um, in the logical design, it would be nice to have a wiring diagram. If you're not able to get the wiring diagram done for the logical design, you can submit it with the physical design. And then ideally by June 30th, we'll have a engineering model done. So you'll have a working CubeSat that you've put together with your students at that point. Because the ultimate goal is to fly your experiments on the high altitude balloon missions that we're going to be doing during our summer workshops in Las Cruces. So we're going to be doing two balloon missions. One will be on July 12th, and then the other one will be on July 16th during those two sessions of um, the summer workshops. If not, we can organize to send them up on a later flight if that's necessary. All right, so I had mentioned that there was a shared folder. So I'll show you exactly what that looks like. So you should have a link to that now, and you will see this right here. So if you open up the experimental proposals, that's all that's here at the moment. What I'll do is I'll make more folders for the various milestones. So the first milestone was the proposal. Next milestone will be a logical design. I'll have a folder of those. And then after that will be the physical design. So looking at those uh, proposals, thank you very much for submitting those. Um, I wanted this meeting to kind of be a chance for us to take first looks at these proposals. If you have any questions so far, you're more than welcome to answer or try to get answers for those. I will either answer them immediately if possible. Otherwise, I will get back to you, within the next couple of days with, anything that I can come up with. So I'm going to start with Arcelia and her proposal. This is a really interesting proposal. Ultimately, it is about um, you know testing different materials to see how they absorb and emit heat when exposed to the sun in space. So this is a great type of experiment. It's not super complex. You'll definitely be able to do this type of testing with off the shelf components. I put recommendations at the bottom of each of the proposals just based on my first look at these. So, Arcelia, for yours in particular, um, I would recommend trying out one of these types of sensors here that I've linked here. This is a probe type sensor. So, sensors that we've used in our workshops previously, the very first workshops that we did back in 2022, we used these types of probe sensors. But then we switched to ones that don't use a probe. They just have the sensor right on the little breakout board themselves. The reason why I think maybe these probe sensors might be better for your particular experiment is that you could attach the end of the probe directly to the material that you're trying to test, so that it'll be able to, see exactly how that material is heating up or emitting heat or cooling down after it's not exposed to the sun. So I think that that would be more useful than using the type of sensors that we used in our most recent workshop together, because that would just be like inside of the CubeSat, and you would only be getting the ambient temperature inside the CubeSat. I mean, you can still do that. I mean, different materials would probably heat up the inside of the CubeSat at different rates, but I think that this would get you a more accurate reading of the material itself. Something to keep in mind is that you want to consider whether or not you'll have to use multiple CubeSats for multiple materials. So the thing with these sensors, is that the way that you hook them up to the Arduino, you I don't know off the top of my head if you can, um, have more than one of these sensors going into a single Arduino and be able to get usable data. Um,
I do have the one that we made, and then the other one that for the students. So I would be able to have at least two
okay,
cubes,
well there you go.
and then so would I eliminate the temperature one and just use this one and keep the gyro and the or how would
So
that
the
work?
temperature sensor that we did use, used I2C. So
Mm-hmm.
if you remember, that was using the SCL and the SDA ports
Uh-huh.
right here.
Uh-huh.
So you could keep that on there
Okay.
and get the ambient temperature inside the CubeSat, and then you can also have one of these plugged into
Okay.
these other spots here, and so you could get both readings, the reading from the material itself as well as the inside of the CubeSat if you want. You don't have to do that, but that is an option for you.
And then if I do this one, the wiring and everything, I would be able to find it on
Yep. So
yeah,
if you get this particular
and
sensor,
then
and
go.
this is from
Uh-huh.
Adafruit, which is technically it's like a local company because a lot of the companies that you buy sensors from will be overseas. A lot of them are in China. This one is
Mhm.
based in New York City. Um, so a great thing about Adafruit as a company, number one, they produce some of the highest quality sensors, but
Mhm.
almost every single one of their sensors has a learn section on the page where you buy it. And if you go to this learn section, it gives you all sorts of information about the sensor itself, what the different pins are, how to,
Mhm.
connect everything together. This particular sensor lets you use either a 2-wire or a 3-wire probe. And so if you go through here, you can see exactly what that means. So once you hook it up, you can use different versions of these probe sensors. So,
Okay.
here's a 3-wire, here's a 4-wire, and then they even have a 2-wire. So, I would recommend going through this, maybe even with your students,
Mhm.
and reading up on the different reasons why you might want to use a 4-wire versus a 3 or a 2. But it
Okay.
gives you options, so there's a lot of flexibility with this.
Okay. And so for this one, do I get it, or would I contact you, Andrew, and we get it that way, or I go ahead and purchase it?
Uh, am I off mute?
Yes.
Whichever way you want to do it. I mean, we'll reimburse you for it. It might be easier if you ordered it and then just let
Okay.
me know how much it was,
No, no
or you
problem.
can send it to me. I just want to make sure that you guys get the right one.
Okay. Sounds good. Thank you.
Mhm.
Yep. And so I've put links directly to any of the sensors that I've recommended right in your proposals that are in that shared folder. So you can just click right on there and it'll bring you to that sensor.
Thank you.
Arcelia, do you have any questions at this point? Anything that you wanted me to clarify for you?
On the material, if the students select to do like the aluminum, something aluminum, I would think something heavy, not heavy, but the material, how heavy would you recommend it being or not being? So plastic, I would say plastic, it would be simple. I could get just, but if they do select aluminum, something.
I mean, aluminum itself is actually pretty light.
Mhm.
I mean, what were you thinking about as far as the material? Were you just thinking that you would wrap the sensor in the material, or were you thinking of like making
Uh,
a side of the
the
CubeSat?
sides, the kids were thinking the sides. They're thinking that they're gonna be able to shape them into the sides. But they said right away foil paper, but I said no because they'll get punctured. Foil paper is too thin. Plastic, I could see it happening like a little bit of a cardstock if they were to
Mhm.
select that, but
Yeah, I
that's
mean, I'm thinking aluminum will be fine. Aluminum is not a very heavy
no
material.
okay.
If you were trying to use lead, I would tell you like, okay, that might get a little heavy, but I don't think that you're gonna really run into a problem. We're trying to keep the cubes under a pound each.
Mhm.
So I mean that still gives you quite a bit of weight to work with.
Okay, sounds good. Thank you.
You're very welcome. Any other questions that you can think of right now?
Not right now. When
All right.
the kids start asking me, probably.
Yeah. And just all you got to do is to send me an email. Um, I can either answer your questions by email, or if it's even better, we could set up a video call with you and your students if you want. I can answer the students directly, whatever is most convenient.
Yeah, like last year, that was very helpful. So probably that what we would do.
Okay.
Thank you.
You're very welcome. All right, let's move on to Diana's proposal. So this is a proposal having to do with the ozone layer and protection that it provides from ultraviolet radiation. This is another great experiment. I think that this is one that will have has real impacts on us humans, as we are affected by UV radiation every time we go outside. Um, so for my recommendations, I put a this multifunction environmental sensor. This is from DF Robot. Um, this is a sensor that I have actually had experience with. I've used this particular sensor. It's a great sensor. Um, it might be a little bit more expensive than some other sensors at about $25, but you get a lot of different data from it. It's basically four different sensors in one. And instead of trying to go with cameras, which number one, cameras are kind of difficult to use with Arduinos to begin with. Cameras are generally something you'd want to use a Raspberry Pi if you were going to use cameras. This has a UV sensor built right into it. And so you're going to get, I think, more precise data about UV radiation by using a purpose-made UV sensor. And beyond that, you're also getting temperature, humidity, pressure, and ambient light as well, which might be interesting to see. Based on what I was reading here, you might want to part of your testing might be to see if different materials, how they block UV radiation. It might be interesting to see the difference in the amount of just ambient light versus UV radiation that gets detected. So this one sensor will basically do everything that you need. You I think I saw on here that you may have also wanted to use no. I mean, if you just use this one sensor, this will get everything that you need and more. So that would be my recommendation. Um, this company, DF Robot, is a Chinese company, but they're one of the higher quality Chinese companies that I have gotten sensors from. So you don't have to worry about getting low quality from them. Just keep in mind that if you do order from them, sometimes it can take a couple of weeks to actually get here. I don't believe that they do any shipping from the US, but they might. So just keep that in mind when you're ordering. And just like on the Adafruit website, this is another reason I like DF Robot. They also provide you with all sorts of information about the sensor itself, how to hook it up to your Arduino. Down here in this document section, you have this product wiki. If you go here, tons of information about the sensor. They show a different type of Arduino on here. But it's pretty much the same stuff that we did in the workshop because this uses I2C or I squared C, which is that SDA and SCL pins that we did in the workshop. And then you just have to hook up the ground. And this runs on 3.3 volt, which looking at these guys. So the particular Arduino Unos that we worked with can give you that 3.3 volt uh, power that you need to use with this. Um, yeah, do you have any questions?
So as far as for the wiring, so it since you said that it works with the same one that we had before, we should not, I guess, encounter many issues
No,
while connecting this. Okay.
nope. I mean, it's really that simple. It's only 4 wires that you need to hook up to it. It's very similar to most of the sensors that we worked with in the workshop. If you go back and look at those, it was just 4 wires for almost every single sensor. It's power, ground, and then the SDA and the SCL. That's it.
And then you mentioned you brought something up about also like materials and things like that because um, the I mean the kids were saying that about the pictures and all of that because they wanted to see, I guess, if they were able to uh, correlate the whatever radiation they got heating certain spots.
Hmm.
um, so like having like samples of I don't know, tiny sample of like sand, or I don't know. I'm gonna, I guess, go back and brainstorm about
Yeah.
that.
Yeah. So, I mean, based on what you wrote here, it seems like they want to know where like
Mm,
the UV radiation is, right?
like where it might be hitting harder than others, or
Right.
I don't know if the area is gonna be like about the same.
Hmm.
We might have like to. I mean, if we really wanted like to compare it, we might have to go all around the world. But we're just going in a small area. But
Yeah. So, I mean, a recommendation that I would have is do readings in different
mhm,
places on the ground. And then when it
mhm,
comes time for the actual flight, we'll be able
mhm,
to use the data from the CubeSat
okay.
along with time as well as the tracking information to determine where the CubeSat is at certain times during the flight. So you'll be able to correlate between location, altitude,
Mhm,
and your data readings. So that should give you some idea of how much UV radiation is it detecting, low to the ground, higher up, all the way at the edge of the atmosphere. So you're
mhm,
going to be able to kind of see that in your data. Something else I would keep in mind is when you do hook this up to your CubeSat, you're going to want to have the actual sensor in a position where it's likely to have the sun shining on it.
mhm,
So the way that we did the CubeSats in the workshop, you might want to reconfigure, how it's facing, because in the
mhm,
workshop, the
yeah,
sensor, if you were to just like put it directly into the CubeSat as it is,
mhm,
you probably wouldn't get as much direct sunlight on it. So that's something to keep in
mhm.
mind. Um, if you need help figuring that out,
Okay.
I'm always available. I can, give you some ideas. But I would pose the question to your students first, like ask them,
Mhm.
how can we set this up so that we're able to make sure that the sensor is actually getting direct sunlight on it.
Okay. Sounds good.
Any other questions at the moment that you might have?
Not at this time, but I'll get back to you as we go more through as
Okay.
we go through this. Yes. Thank you.
Certainly. All right. And then the last one that I've received so far was from Gary. This is an interesting one. So this is looking at solar radiation as well as effects on the ionosphere and the thermosphere, and it includes GPS. So these are some very interesting sensors that you might want to use. I see that you put a couple of those sensors in there. I added some more that you might want to take a look at. So you have a magnetometer on here, which is just three axes. So you have your X, Y, and Z axis that the magnetometer could detect. I found this sensor from Adafruit that is actually 9 axes. So you have 3 axes for 3 different types of sensing. You have an accelerometer, so 3 different axes on the accelerometer, a gyroscope, and a magnetometer. And looking at the price difference, this is only going to be about twice as expensive. It's going to be $20 as opposed to like $10. Um, but you have to also consider the sensor that you were looking at was a DF robot sensor from China. So the shipping will probably be more than if you're ordering it from Adafruit. So I don't think it's going to even be quite twice the cost, but you're going to be getting 3 times the amount of data because you've got 2 extra sensors on there. Um, you don't have to go this route. You already have a 6 axis. You have the accelerometer and the gyroscope already. But if you wanted to like simplify it and only have just this one sensor, that would be a route to go. If you want, you can also look at magnetometers on here. So like if you just do a quick search on here. Like here's another one. Here, this is only 595. That's just the single magnetometer. They've got all different varieties. I would do what I suggested to everybody else already. If you go on Adafruit's website, you go down to this Learn section, and you can find all sorts of information about this particular sensor, how to hook it up, uh, what its sensitivity is and whatnot. So definitely recommend going through the Adafruit website, taking a look at everything, comparing it to the DF robot sensor that you already have on your on your proposal. See what makes the most sense. And then you also had a gas sensor on there, and I put another recommendation on here. So this is a pressure, humidity, temperature, and gas sensor. This has all of it in one sensor as well. And the cool thing about these particular types of sensors is that they have these hookups where you can daisy chain multiple sensors together. Makes it a lot easier instead of having to use these connections down here and connect each individual sensor or each individual connection to a breadboard and whatnot. You don't even have to use a breadboard with these types of sensors. You buy the Stemma QT connectors. You plug this into, say you have like 3 of these sensors that have these Stemma QT connections on them. You can just plug one into the other and then plug those into the Arduino, and it just makes life a lot simpler. That's actually what I wound up doing for one of our Blue Origin CubeSats. I didn't even have to use a breadboard. I was able to just connect all the sensors directly to each other. But again, it might not make sense for you. You do already have temperature and pressure, I believe. Yeah, you have a temperature pressure sensor already. If you wanted to have humidity as well, it might make sense to just get this one sensor and have it all in one little package.
Okay,
So
that's pretty good. I like those recommendations.
okay, good, excellent.
Yeah, that's
Like
something that we can better than the DF robot, because we just don't know how long it would take for the sensors to get here.
right, right,
Um,
exactly.
so I like the idea as far as, because it had the temperature.
Hmm.
Um, I was just thinking about space on the
Yeah,
breadboard.
Yeah, I mean, this will save you. Well, and keep in mind that if you do go the Stemma QT connector route, you don't even need to use a breadboard. You might have to figure out how you're going to connect it to the Arduino itself. So if we go to the Cduino page real quick. So this is the actual microcontroller that we used. Here you can see that they have these connectors, the SCL SDA plugs right here. This is, I believe, what's called a Grove connector. Yeah, it's got Grove. You can probably find a Grove to Stemma QT connector. Looks like Adafruit has one right there. Boom. So you would be able to buy one of these connectors. You can plug this end directly into the Arduino, and then the other end goes into the sensor. And then if you have multiple sensors that have these Stemma QT connections, which the ones we used in the workshop, almost all of them have this on them. You just buy the Stemma QT connectors as well, these guys, and you can just plug one sensor into another sensor. You don't even have to use a breadboard at all. So that could save you a bunch of space and some weight as well.
Noah,
So
could you add that link to the
yes,
proposal if you don't mind?
Yep.
Appreciate it.
No, is that like a really good connection, a real strong connection? We wouldn't have to worry
yeah,
about any
you don't
kind
have to
of
worry about it coming
vibration
out.
loosening
Nope,
them?
I don't think
No,
so.
okay.
So like it has an actual like connector on the end there that would, latch on. And then these guys, it worked on a Blue Origin rocket. We didn't have any problems. I think there's going to be a lot less vibration on a balloon or a glider than on a rocket. So
Right. Yeah.
I think that we have proven
No,
that these particular types of connectors work well. Other questions that you guys have, Gary and Richie?
no,
No.
sir.
All
We
right.
might just need your help, maybe
Yeah.
connecting virtually as far as
Yep.
the software and connecting those sensors. So
Absolutely. That's what I'm here for. So all you gotta do is just shoot me an email if you want to do a video call or a phone call or just emails back and forth, whatever is convenient for you is fine with me. All right. So I mean, that's essentially what I wanted to do for this meeting. I wanted to, just go over your proposals real quick. Just show you some of the recommendations that I had, answer any questions that you might currently have, and just let you know that I'm here for you if you should need me.